Okay, so we want to derive the Einstein equations given this metric that is not static with this ht term. So let's remind ourselves that g naught naught is, if we keep speed of light, minus c squared, g11, g22, and g33 are all h of t. So let's start deriving the connection coefficients. So we could start there, of course, natural place to start. We won't go through all of them. We'll argue by symmetry here that certain things will be the same. So this becomes 1/2, right? We have the inverse, g naught naught. Well, let's just go through this. It's 1/2 g 0 d. We're summing on d. Then we have derivative g d0 with respect to x0 plus derivative of g d0 with respect to x0 minus derivative of g 0, 0 with respect to xd. And given our metric, of course, there are no off-diagonal terms, so d equals 0 is the only one we care about. So that's why it was okay that we choose d equals 0, but we just want to show where it comes from. This is g 0, 0 and x0 plus g 0, 0 again and x0 minus g 0, 0 and x0. So, but g 0, 0 is a constant, so it doesn't depend on time. So this is going to be equal to 0. Gamma 0, 1, 1. I'm going to 1. That's not going to be 0. This has 1/2 g 0 d d g d1 in x1 plus d g d1 in x1 minus d g11 in xd. Again, only d equals 0 matters. So we have dg01, that's already by itself 0, we'll just write it out, plus dg01, that by itself again is 0, x1, minus dg11 with respect to x0, and this is minus 1/2 g 0, 0. I'm pulling out the minus sign here. dg11 with respect to x0, which is well, g 0, 0 is just the inverse of this, so it's minus 1 over c squared. So here we have 1 over 2 c squared dh with respect to t, because x0 is time. So it looks like that. So that's 0, 1, 1. But we have a symmetry here, and so this is 1 is x. So we could argue that gamma 0, 1, 1 is equal to gamma 0, 2, 2. Which is equal to gamma 0, 3, 3. So all of those are equal to that. And now we'll move on to, let's see, gamma. Right, we won't go through all of them. We know which ones are going to survive, but gamma 1, 0, 1. And of course, there's a symmetry that we can, again, appeal to in the metric. So this is equal to 1/2 g 1d. Only d equals 1 is going to matter here, but let's just go through it. G d1, to remind ourselves where this comes from, dx0 plus derivative of g d0 in x1 minus derivative of g 0, 1 in xd. This gives us 1/2 g11 the g11 in x0 plus the g10, that by itself is 0 in x1 minus derivative of g01 in x1. Oh, that by itself is 0. So this gives us 1/2 g upper 11 the g11 in time, or x0, and that is 1 over 2, right? Inverse of this is 1 over h, so we have a 1 over h here. 1 over 2h of t, derivative in time of that same thing, derivative of h of t in time. And so, again, by symmetry, we can argue that gamma 1, 0, 1, we don't have to figure out the gamma 2, 0, 2 and the gamma 3, 0, 3, because they're all the same, and we won't go through the other ones, which will all end up becoming 0 anyway.